Today, I want to take you back through factoring quadratics. This is a concept that you should have used already in Math 1, but I do want to revisit. Some of these may be a little bit more complicated than the ones you did. You may have just done basic factoring. So I'm going to go through many of the different ways that we can factor quadratics today. I'm going to start with just basic factoring a trinomial where the leading coefficient is 1. So let's talk about what these look like. Let's say we have basic quadratic ax squared plus bx plus c. And this is what we want to factor. And we're going to start with the types where a is equal to 1. Okay, so that leading coefficient with the x squared is going to be equal to 1 for these first sets of examples. Okay, the way that we want to factor this, so we're going to have a plain x squared plus bx plus c. We need to be looking for two numbers that add together to equal whatever the b number is, whatever that coefficient with the x is, and those same two numbers we want to multiply together to equal c, whatever that constant is. Okay, so those are the numbers that we are looking for in order to be able to factor this and break it down. So let's take a look at an example. Let's say that we're starting out with x squared plus 9x plus 20. And we want to factor this. So again, remember what I said to start with. We need two numbers that add together to equal the number with the x. In this case, that is a 9. And then we need the same two numbers to multiply together to equal the number by itself, the c constant, which is positive 20. Okay, so we need two numbers that fit that. Now, this should be pretty easy to figure out. If not, you can start going through your factors for the number that you have to multiply for. Think about 20. We have 1 and 20. That's not going to work. We have 2 and 10. Not going to work. 3 doesn't go into it. 4 times 5 is 20. And now we found our set. 4 plus 5 gives us 9, and 4 times 5 gives us 20. Now that we have these two numbers, we want to factor this expression. So you want to have two different parentheses. You're going to have x at the beginning of each of those. And then you just want to input your numbers in whatever sign they have. So we both have positive 4 and positive 5. So we're going to have x plus 4 and x plus 5. So that would be the factored expression for x squared plus 9x plus 20. Let's try another one. Okay, let's say we have x squared, oops, not plus, let's do minus 22x plus 21. Now, last one we had everything positive. This time, notice we have a negative with the x. So this time we're looking for two numbers that add together to equal negative 22 and multiply together to equal positive 21. If you start thinking through your factors that could work, that's going to be negative 1 and negative 21. That will work for both of those. That will add together to equal negative 22 and multiply together to equal positive 21. So then again, remember, set up our parentheses, x's go first, and then we use our numbers with whatever sign we had. So both of these are negative, so we're going to have x minus 1 and x minus 21. Okay? All right, let's try another one. This time, we're going to have two negative terms. Let's say we have x squared minus 7x minus 18. Okay, we want to do the same process. We need two numbers that add together to equal the number with the x, which is negative 7. And the same two numbers need to multiply together to equal negative 18. So the big thing here, notice we're multiplying to equal negative 18. That means one of our numbers has to be positive and one of our numbers has to be negative. And we want to work it out in a way that we get negative 7 when we add those two numbers together. So right away, we should be thinking of 9 and 2 because those are going to multiply to 18, and there's a way for us to get those to negative 7. In order to get them to add to equal negative 7, the 9 would have to be the one that's negative. Okay, so notice negative 9 plus 2 gives us negative 7. Negative 9 times 2 gives us negative 18. So again, Let's write out our parentheses, put our x's, and then we keep these with the signs they have. So we have x minus 9 and x plus 2. Now, another thing to note, it does not matter which order you have these in. So that last one we could have written as x plus 2 times x minus 9, and that would have been completely fine. It does not matter which order as long as you have the correct signs with them. Okay? All right. So those are pretty easy. Let's take a look at another type called a difference of squares. So this is when we have squared terms, and there's a difference, so there's subtraction in between. The formula for this, if you have a squared minus b squared, you can factor that to be a plus b times a minus b. So you take the square roots of each number, one time you add them, one time you subtract them, okay? Or expression. It may be an x squared, in which case the square root would be an x. Okay, so let's take a look at a couple of examples like these. Let's say we have x squared minus 25. Okay, notice we do not have a plain x with this type of term. Okay, so in that quadratic formula, we don't have the b term. We don't have a number with the x. So looking at this one, we just have our a and we have our c. Okay, now when we take the square root of each one, we want to factor this. Again, we're going to have two sets of parentheses. Take the square root of each one. Square root of x squared is x. Square root of 25 is 5. So we're going to put that in both places. And then all we have to do, one time we add it, one time we subtract. So x squared minus 25 is x plus 5 times x minus 5. Now, you can also solve this one using the method we just looked at before. Think about what we said. The b term is 0, so we would need two numbers that add together to equal 0, so they in effect cancel each other out. The same two numbers would have to multiply to equal negative 25. So what would work? 5 and negative 5. Okay? So we could have solved that one this way, but it's a lot faster. If we recognize that this is a difference of squares, we can go ahead and just take the square roots and one time add, one time subtract. Okay? They may get a little bit more complicated. Let's take a look at one that's a little bit different because it's got some higher numbers and it's got a number, oops, I don't need a parentheses yet. It's got a higher number with the x squared. Okay? First of all, again, we only have two terms. We have subtraction, so we have the difference. And then notice that we have perfect squares. 100x squared and 81 are perfect squares. So that's our clue that this is a difference of squares. So we want to go ahead and break these apart. Okay, we've got our parentheses. Then we want to take the square roots of each one. Square root of 100x squared would be 10x. Square root of 81 would be 9. One time we add, one time we subtract. And we're done. Okay, let's take a look at one more. It's a little bit more difficult. We have an extra step here. Let's say we have 3x squared minus 48. Now you'll notice 3 and 48, they are not perfect squares. So even though we have terms here and we're subtracting, so our first thought is probably like, this might be a difference of squares. If we look at the actual numbers, it's not. However, think about something they have in common. 3 and 48, they're both divisible by 3, aren't they? So we could pull out a 3. If we divide each term by 3, 3x squared divided by 3 is just 1x squared or x squared. Negative 48 divided by 3 is negative 16. Now take a look. X squared and 16 are perfect squares. We want to leave that 3 on the outside because we did take it out. It is part of the problem. Okay, it is part of the expression, so it's going to stay there. Now, let's factor our difference of squares. Square root of x squared is x. Square root of 16 is 4. One time we add, one time we subtract. So the factored form of this one is 3 times x plus 4 times x minus 4. Speaking of squares, there's another one that we need to take a look at called perfect squares. Okay, so this is when we have a term, a binomial that has been squared out. We're trying to factor it back to that term. So let's take a look at the formula for this. Okay, we have a squared plus 2ab plus, it doesn't look, there we go, plus b squared. That is equal to a plus b all squared, which is the same as a plus b times a plus b. We have a squared minus 2ab plus b squared. That's equal to a minus b all squared, which would be the same as a minus b times a minus b. Okay, just so we know. Okay. Remember, when we square something, we multiply it by itself. So let's talk about an example. Let's see what this might look like. Still are going to have three terms. So let's say we'll start with a pretty easy one that we could factor a different way, just so we can see it both ways. Okay, so we have three terms again. We have a trinomial. Take a look at your first term and your last term. X squared, perfect square, 36, perfect square. Okay, and then we have plus 12x in the middle. So here's what you want to take a look at. If we were to take the square roots of those, we'd have x and we'd have 6, right? Take a look at this middle term. Now we have all pluses, so we're looking at this top one. Take a look at the middle term here. Plus 2ab. So what we're saying is that x is the a, 6 is the b. If we multiplied those together and doubled it, okay, a times b would be x times 6, which is 6x. If we double that, that would be 12x. Notice that's the term we have in the middle. So this fits the formula. So we could say that this is equivalent to x plus 6 squared. Another way quick to just show you that we would get to the same answer if we used our method we first talked about in the video. Think about how we would solve that when we would need two numbers that would add together to get 12 and the same two numbers multiply together to get 36. What two numbers do that? 6 and 6. So we would have had x plus 6 times x plus 6, which is the same as x plus 6 squared. Okay? Let's take another. This is probably one of the most difficult ones that people struggle with. So let's take a look at another one. Let's say we have 9x squared plus 24x plus 16. Okay, again, we have three terms. We don't have anything in common that we could take out. There's nothing that 9, 24, and 16 all have in common. So now we're taking a look at how could we break this one down? What are some things we notice? 9x squared and 16 are both perfect squares. So our first thought now should be, does this fit the perfect square model? So let's take the square roots. We'd get 3x and we'd get 4. Okay, remember what was supposed to be in the middle? 2 times those terms multiplied together. So 3x times 4 is 12x. If you double that, you get 24x, which matches. Notice that everything's plus, so this is 3x plus 4 all squared. Okay, and let's try one more. This time we're going to have a subtraction in here. So let's look at 49x squared minus 14x plus 1. Okay, again, we have three terms. And our first term and our last term are perfect squares. 49x squared and 1 are both perfect squares. So let's see if it fits the model. Take the square root of each one, 7x, 1. Now, remember in the middle, we should have 2ab as a term in the middle. 7x times 1 is 7x, times 2 is 14x. Notice that it is subtracted. So this is 7x minus 1 all squared. The last type of factoring that we're going to talk about is when a is not equal to 1. So remember how we wrote out our quadratic equation. We're still going to start the same way as we did to begin with. We still need two terms that add together to equal b. But now we need two numbers that multiply together to equal whatever a times c is. Okay, so this one's going to go a little bit differently. Let's follow through. Let's look at an example, and I'm going to take you through the process. Okay, we end up factoring by grouping, basically. Let's start out with this one, 6x squared plus 11x plus 4. Okay, so when we see this one, we'll notice that we have three terms. Okay, there's nothing we can take out that they all have in common. 6, 11, and 4 cannot be divided by the same number. And then if we were to try to look to see if they fit a perfect square model, notice that 6x squared is not a perfect square. 6 is not a perfect square. So we have to factor by grouping, basically. Here's the process. Again, we needed two numbers to add together to equal the middle number. In this case, that's 11. And then the same two numbers need to multiply together to equal a times c, which is 6 times 4. Okay, 6 times 4, 24. Okay, so let's start thinking through our factors. 1 and 24, not going to work. 2 and 12, not going to work. 3 and 8, now we've got it. 3 plus 8 is 11. 3 times 8 is 24. Okay, now with the first type, we just went ahead and wrote our parentheses and we were done. But that was different because we had a plain x squared, so we could go ahead and do that. Now what we have to do is we have to take our numbers that we found and we want to replace the term with the x. So our beginning and end is going to stay the same. We're still going to have squared. But now instead of 11x, we're going to put in our numbers. Plus 3x plus 8x. Okay, so notice the beginning and end stayed the same, and all we did was break apart that 11x into 3x plus 8x. Now we want to group these together. Okay, so let's group our first two terms and our last two terms. 6x squared plus 3x. This is our first grouping. Is there anything that those have in common that we could take out? 6 and 3 both have a 3 in common. X squared and x would both have an x in common. Now let's think about dividing those out. Okay, if we divide 6x squared by 3x, we would get 2x. If we divide 3x by 3x, we get 1. Okay, let's take a look over here to our second group, 8x plus 4. Okay, they don't have an x term in common, but they do have a constant. We could take out a positive 4. If we divided both of these by positive 4, 8x divided by 4 gives us 2x. 4 divided by 4 gives us 1. Now, if we've done this correctly, inside our parentheses, we should have the same factor. Notice that we have 2x plus 1. So if we take out a 2x plus 1, that leaves 3x plus 4, the other two terms on the outside. And we are done. This is the factored form for 6x squared plus 11x plus 4. Some of you may know the box method. Feel free to use that if you already know it. But this is kind of a more algebraic form. Okay, it's easier to see where the numbers come from. There's less guess and check with the signs. All right, let's try another one. Let's say we have, we'll do some negatives this time, 2x squared minus 7x minus 4. Okay, again, three terms. You can't factor anything out, and both of them are not perfect squares. So we're going to use our other method. We need two numbers that add together to equal the term with the x, which is negative 7. And the same two numbers need to multiply together to equal the first times the last, 2 times negative 4, which is negative 8. Okay, so we should be able to see pretty quickly we could use negative 8 and positive 1. Okay, negative 8 and positive 1 add together to equal negative 7 and multiply together to equal negative 8. Now remember, we don't just go ahead and write our parentheses. This is where we replace the x term. We'll keep the 2x squared. Now we're going to put in minus 8x plus 1x or just x. I'll put in 1x just to make it a little bit clearer. And then minus 4. Now we want to group the first two and the second two together. Let's take a look at the first group. What do they have in common that we could take out from both of them? We could definitely take out a 2 and we could take out an x. If we divide 2x squared by 2x, that gives us 1x or just x. If we divide negative 8x by 2x, that gives us negative 4. Now, look at our next group. We already have x minus 4 in there. There's nothing we could take out. So let's call it taking out a positive 1. If we divide both of these by positive 1, we're going to get the exact same thing, x minus 4. Now notice that our parentheses match up. We have x minus 4 as our factor in there. So our first factor is x minus 4. When we divide that out, that leaves 2x plus 1. So our two factors are x minus 4 and 2x plus 1. All right. I'm going to do one more. Okay, let's say we have 6x squared plus x minus 2. Okay. Again, 3 terms, can't factor anything out of them, not perfect squares. So two numbers that add together to equal positive 1, because it's just 1x, and two numbers multiply together to equal 6 times negative 2, first times last, which would be negative 12. Okay, we should start working through our factors of 12. And we should pick up pretty quickly that we're going to use 4 and 3, and we need it to add to positive 1, so let's use 4 and negative 3. Okay, so remember, next step is to replace the x with those two terms. So plus 4x minus 3x. Notice all we did is replace that x. This is still an equivalent expression. Let's group our first two and our second two. Look at that first group. What can we take out of 6x squared plus 4x? They would both have a 2 and an x in common. If we divide them out, 6x squared divided by 2x leaves 3x. 4x divided by 2x leaves 2. Now, take a look at that second set of terms. They are both negative. However, in our parentheses here, both our terms are positive. So let's take out a negative 1. We can't take any other numbers out or any x's out, so let's take out a negative 1. If we divide both of those by negative 1, we end up with positive 3x plus 2. Now notice that our parentheses match up, so our two terms, the two factors, are 3x plus 2 and 2x minus 1. All right, guys, I hope that's been a good overview of factoring. We will have quite a few practice problems with this. If this is brand new or a refresher, either way, it's very good to go back over these before we move on.